Good morning, my dear students. In this particular video presentation, we'll discuss some more problems meant for some competitive examinations or JEE, whatever it may be. To do one problem on trigonometry, we have to do some basic results. The first result goes like this, which is also known as sine rule in a triangle. Sine rule in a triangle. Just listen carefully. With usual notations, prove that in triangle ABC, small a by sine A is equal to small b by sine C is equal to small c by sine C. By usual notation, you mean the sides opposite to angle A, angle B, angle C, or small a, small b, small c respectively. I repeat, the sides opposite to angles A, angle B, angle C of triangle ABC are considered to be small a, length small a, small b, small c. That is the meaning of usual notation. Each of these ratio to be is equal to 2 capital R. R is nothing but the circumradius, radius of the circumcircle. It's not a difficult task. Let me just draw the diagram. Just see here. It is an easy task. Just listen. See here, I have drawn the circumcircle. Okay, I have drawn the circle, triangle also. Okay, now this length is anyway A, this length is B, this length is C, let us say. I'll just take O to be the center of the circle. I'll assume O to be the center of the circumcircle. Okay, just see here. I will just draw OD perpendicular to, let me draw OD perpendicular to BC. Listen carefully. O be the center of circumcircle of triangle ABC. I assume it to be O. Now, you might have seen degree measure theorem in lower classes. The degree measure of an arc of a circle is twice the angle subtended by it in any other point in the alternate segment. Therefore, here I mean to say angle BOC is twice of angle BAC. This is by degree measure theorem. This is by degree measure theorem. Angle made by arc BC, this is my arc BC, is twice the angle at any point in the other segment, alternate segment, of course in arc CB. A is a point in arc CB. That's the one you are supposed to remember. Okay, now angle BAC is nothing but angle A. Remember that carefully. Now draw OD perpendicular to BC. Now in triangle ODB, triangle ODC, you mean to say OD is equal to OD, common side. Those two are common sides. Okay, common side. Next, of course, OB is equal to OC. OB is equal to OC is equal to capital R. This is the circumradius. Angle ODB is equal to angle ODC is equal to 90 degrees. That's how the construction is being done. Therefore, triangle ODB congruent to triangle ODC, you mean to say by RHS congruence. RHS congruence. Right angle hypotenuse, one of the sides of a triangle are equal to the right angle hypotenuse and another side of corresponding side of another triangle. Therefore, here I mean to say DB is equal to DC is equal to half of BC, which is nothing but A by 2, which is this length will be A by 2. Now similarly, this is called CPCT, corresponding parts of congruent triangles. Then I mean to say here angle BOD to B is equal to angle COD, each is equal to half of angle BOC, which is half of angle A. And that is simply angle A. Twice BOC is twice of angle A, therefore it's nothing but angle A. It's as equal as angle A of triangle ABC. Okay, not half. Okay, now this is my angle A. Now in triangle ODB, let me apply sine A. Sine A is nothing but A by 2 by R, which is A by 2R. Therefore, I'll end up with A by sine A is equal to 2R. Similarly, we'll be able to prove B by sine B is equal to 2R and C by sine C is equal to 2R. Okay, therefore I mean to say finally A by sine A is equal to B by sine B is equal to C by sine C. Each will be is equal to 2R, where R is the circumradius of triangle. Circumradius of triangle ABC. Okay, radius of circumcircular triangle ABC. That's the meaning. Let me repeat the whole process. Assume O to be the center of the circumcircular triangle ABC. Now angle BOC is twice of angle BAC by degree measure theorem. Now let me draw OD perpendicular to BC. In triangle ODB, triangle ODC, OD equal OD common side, OB equal OCC equal same radius capital R, and angle ODB equal angle ODC 90 degrees. Therefore, RH is congruent, those two triangles are congruent, which will imply you DB equal to DC is equal to half of BC, which is small a by 2. Now these two angles will also be equal. Here I'll be able to write CPCD, corresponding parts of congruent triangles. Now for I need to say half of angle BOC. Angle BOC is twice of angle A. Therefore half of twice will give you angle A. Now in this triangle, if I apply sine A, opposite side by hypotenuse A by 2 capital R. Therefore bring sine A down. Therefore I mean to say A by sine A is equal to 2R. Similarly, if I draw perpendicular here from 1 to AC etc., if I do the same manner, I mean to say B by sine B is equal to 2 capital R. C by sine C is also 2 capital R. I can name this 1, 2, 3. 1, 2 and 3 will imply you automatically. A by sine A is equal to B by sine B is equal to C by sine C. It's an easier result, of course. It's not at all a difficult result. Just go through once again. It's not at all difficult. You need to just apply your mind to understand. It's not at all a difficult task. I don't want to take it for granted to apply in one of the problems. But I'm giving you the necessary results, how to get the proof, etc. Just see here. Okay. This proof may not be given as it is in your competitive examination, but I want you to know how it comes. Therefore, I'm giving the proof for you, for your sake. Okay, secondly, in triangle ABC, second result, in triangle ABC, prove that A is equal to B cos C plus C cos B. That's what I'm supposed to prove. In triangle ABC, prove that small a is equal to B cos C plus C cos B. Okay. B cos C plus C cos B. Just it's not a difficult task. Just listen carefully. This length is A, this length is B, this length is C, let us say. Just draw AD perpendicular to this. Draw AD perpendicular to BC. Just listen carefully. Okay, just listen. In triangle ADB, let me apply cos B. Cos B is nothing but BD by C, which implies BD happens to be C cos B. Now similarly in triangle ADC, let me apply cos C. Cos C is nothing but DC by small b. Now for DC is nothing but B cos C. Now BC can be replaced by A. BC can be written as BD plus DC. Can be just BD is replaced by this value C cos B. And DC is replaced by B cos C. Therefore, A becomes B cos C plus C cos B. I am writing this at the beginning just for easy to remember. Formula can be remembered easily. A is equal to B cos C plus C cos B. Similarly, I can prove B is nothing but C cos A plus A cos C. Similarly, C will be equal to A cos B plus B cos A. It's easy to remember. Similar results we should know. A is equal to B cos C plus C cos B is one of the results. Similar result, I will have B is equal to C cos A plus A cos C, and C will be equal to A cos B plus B cos A. It's easy for you to remember. Okay, I think it is easy for you to remember. It's not at all a difficult task. Okay, just go through. It's not at all a difficult task. Okay, then I have one more result to be remembered. Okay, I have one more result. Just see here. Show that A cos of B minus C is equal to B cos B plus C cos C. Let me just see the result. Let me start with LHS. A cos B minus C can be written as 2R sin A. Oh, sorry, I'll check the result whether it's right or wrong. Yeah, it's correct only. 1 second. 2R sin A. Just now we have seen. Okay, 2R sin capital A. 2r sine A cos B minus C. Therefore, I mean to say 2r sine pi minus B plus C into cos B minus C. Just listen carefully. It's not at all a difficult task. Therefore, here I mean to say, actually this is because of sine rule which we have seen just now. Now listen carefully. R into 2 sine B plus C into cos B minus C. I'll be able to write. Which is, of course, 2 sine A cos B is nothing but sine A plus B plus sine A minus B. Let me just use that rule. Sine B plus C plus B minus C plus sine B plus C minus B plus C. Therefore, it will get reduced to R into, here C gets cancelled, sine 2B plus sine 2C. This is, let us say, my LHS. What happened to my RHS? Let us say RHS is B cos B plus C cos C, which is 2R sine B cos B plus 2R sine C cos C, because of the rule which I gave you just now at the beginning. Therefore, let me just take R as common. This will become automatically sine 2B plus sine 2C. This is equation 2. 1 and 2 will imply you. I get the same reduction. Therefore, I end up with A cos B minus C is equal to B cos B plus C cos C. Let me just repeat this process again. Okay, let me just repeat. A cos B minus C is 2R sine A cos B minus C. 2R sine A plus B plus C is pi. Therefore, A is pi minus B plus C. Sine pi minus theta is sine theta. Therefore, 2 sine A cos B can be replaced by sine A plus B plus sine A minus B. Sine B plus C plus B minus C plus sine B plus C minus B plus C. Minus minus become plus C. Here C gets cancelled, here B gets cancelled. Becomes sine 2B plus sine 2C, or of this much. Replace B by 2R sine B, replace C by 2R sine C. Taking R as common, 2 sine B cos B is sine 2B, 2 sine C cos C is sine 2C. I get the same reduction. Therefore, A cos B minus C now becomes B cos B plus C cos C. Similarly, I have B cos C minus A will be is equal to C cos C plus A cos A. I'll have same manner I'll have. Similarly, C cos A minus B, I'll end up with A cos A plus B cos B. These are the similar results you are supposed to remember. I repeat, B cos C minus A will be C cos C plus C A cos A. This is C minus A, sorry. Okay, this is A. This angle is A. 1 second. This is not, I over wrote in the same place. Similarly, small c, C cos A minus B is A cos A plus B cos B. These are the results you are supposed to remember. It's already 12 minutes. Therefore, the application of which I'll do in the next video anyway. I'll just check the calculations or method. If anything is, any error is there, I'll correct. Otherwise, I'll upload as it is. Thank you, students, for patient watching.